Welcome to Spring LIB.
Our question says that we have a 9-volt battery connected to a resistive strip, and we can look at 26-26A to see this. And also 26-26B shows the potential versus the position X along the strip, where the horizontal scale at X is set by X sub S is 8.00 millimeters. So section 3 has a conductivity sigma 3 of 3.0 times 10 to the 7 ohms per meter inverse. And it wants to know the conductivity from that of section 1 and section 2. I also write, based upon these graphs, the ratios that you can see of the electric fields relative to one another. So E1 is 1/2 of E3, and E2 is 4 times E3. And the reason I write that this way, E1 relative to E3 and E2 relative to E3, is because we're given sigma 3, and we want to get sigma 1 and sigma 2 from those values, and we're going to use that relationship. Okay, so the absolute values of the slopes are equal to their respective electric fields magnitudes. That's how I did that based upon those figures. And then we can use the equations 26-5 and equation 26-13 and apply these to the 3 sections of the strips. And that's going to give us J1 is equal to sigma 1, the conductivity in 1, times the electric field in 1. J2 is equal to sigma 2 E2, electric field in 2, and then the current density in section 3, J3, is equal to sigma 3 E3. But J1 is equal to J2 is equal to J3. And the reason that this is true is because the values of the current and the values of the area are the same due to the problem, okay? So we can use that symmetry in the problem and set J1 equal to J2 equal to J3. And since we know E1 relative to E3, and we know E2 relative to E3, and we know sigma 3, we can find sigma 1 and sigma 2. So for part A, we have sigma 1 E1 is equal to sigma 3 E3. Okay, so we just plug in the value for E1. So sigma 1 is equal to 2 times sigma 3. Sigma 3 is 3 times 10, 3 times 10 to the 7. I believe I wrote 10 to the minus 7 here, so I think I miswrote that. Let me make sure. Yes, it's 3 times 10 to the 7. So let me erase that minus sign real quick. Sorry about that. Okay, so double that is 6 times 10 to the 7 inverse ohms meter. We can box that in as our solution to part A. Now, doing the exact same thing for part C, using the fact that E2 is 4 times E3. We'll start a new page here. Sigma 2 then must be 1/4 sigma 3. Oops. So plugging in our value for sigma 3, this comes out to be 7.5 times 10 to the 6 inverse ohms meter. We can box that in as a solution to part B.